Today we'll discuss about Hdlc, which is a data link layer protocol, and the full form of Hdlc is high level data link control. It is a bit oriented protocol. Earlier we have discussed about PPP, which is another data link layer protocol, and byte oriented protocol. So basic features of Hdlc are: it is a reliable protocol. It uses selective repeat or go back in window protocol, which we have already discussed in our classes. Then it uses full duplex communication. That means both the parties can talk simultaneously or can exchange data simultaneously. It is a bit oriented protocol, and we have already seen that it uses the flow control mechanism like selective repeat or go back in. It uses physical layer clocking and synchronization to send and receive frames. Now, in our HDLC video lecture, we will discuss these points. There are three types of stations. First, we'll discuss about the stations. The three types of stations are primary station, secondary station, and then combined station. Then we'll discuss about the different types of data transfer modes. And finally, we'll discuss about the three types of frames which is used inside HDLC. So we'll start with the types of stations. Primary station. Primary station is the master's type of station, and secondary station is the slave type of station. That means whenever any data transmission will be initiated, always it will be initiated by primary station. So it is the controlling part among the stations. It handles error recovery, and frames issued by the primary stations are actually called commands. So whenever the primary station sends the commands, secondary station must give the response in return of that, and it always works under the control of primary station. If there are multiple secondary stations, then primary station maintains a separate session with each of these secondary stations. So actually it creates separate logical link with each primary station. That means there is no direct point-to-point contact between each secondary station to primary station, but it maintains a session for each secondary station. That's why it is said logical link. And the third type of station is combined station, which can work both as primary and secondary. So there is no such segregation in this type of station that it is a primary or secondary station. Combined station, it can do the job of primary as well as secondary. Now the modes of communication. First is the unbalanced mode. Here primary station is the master and secondary stations are the slaves. So primary station always issues the command, accordingly the secondary station sends the responses. So here the weightage of primary station is higher than the secondary station, that's why it is called unbalanced. But if we consider about the combined stations, then both the station is of same weightage because they can work as primary as well as secondary. So when they exchange data between them, the combined stations, it is known as the mode of data transmission is known as balanced mode. So first data transfer mode is the normal response mode. Here secondary stations can only send data when primary station instructs. There can be two types of configuration between primary and secondary. One is the point-to-point link. That means primary station is physically connected directly to the secondary station, and then that means there is one primary and one secondary station and they are connected with each other. Then multi-point link, where the primary stations are connected with multiple secondary stations, and for each secondary station primary maintains a session, separate sessions. Then asynchronous response mode, or ARM, which is in this case secondary stations are more independent. They can send data and control information without explicit permission from the primary station, but still it cannot send any command to the primary station. It can send data or control information but cannot send any command to primary station. But in case of asynchronous balanced mode, it is used for combined stations when the combined station exchange data, and it is used when there is a point-to-point link for communication between combined stations. So each station can send data, control information, and commands. So any of these station, because they are combined station, they can be used for as primary and secondary. They can send commands to each other and they can send the responses accordingly. Now the types of frames. There are three types of frames: unnumbered frames, information frames, and supervisory frame. These are the frame structures. This is the general frame structure where in both these end we are having a flag, and this flag we know already when we have discussed bit stuffing. This flag is having a particular pattern. There is 0, then 6, 1, and last 0. It is a 8-bit pattern. This main responsibility of this flag is to segregate the frame from the previous and next frame. Then there is a address field. Which type of address is used here? When primary stations is sending a frame obviously to the secondary station, it is the type of address is to address. That means the address of the secondary station. When the secondary station is sending a new frame, it is a from type of address. That means again it contains the address of the sender, that means the secondary station. And in some case it contains a group or broadcast address. After that, there is a control field and there's an information field. We'll come to the details of that. And then FCS. In case of FCS, it uses a 16-bit CRC with this generating polynomial, basically, which is used for error detection. Now, if it is a iframe, it will be always started with 0. This information part, sorry, this control part will always start with 0, and then there will be a NS part of 1, 2, 3 bits, and at the end there are NR part of 1, 2, 3 bit. So in these 3 bits NS, it sends it is carrying the sequence number of the sending frame, and here in NR it contains the receiver's sequence number, which is basically used for acknowledgement. Then here at the fifth bit, it is known as pole final bit. So what is pole final bit? If primary is sending the data, it is treated as pole bit, and if secondary is sending the data, it is treated as final bit. In case of supervisory frame, the control field will start with first a 1 and then a 0. So it will be started with 1 0. That means it is a second supervisory frame. Then there is a 2-bit S bits, 2 S bits. S bit means supervisory function bits. So what is the function of these 2 bits? If we are having 2 bits, we can have 4 combinations: 0 0, 0 1, 1 0 and 1 1. So if it is 0 0, that means receiver is ready to accept the frame. If it is 0 1, that means receiver is rejecting the frame. If it is 1 0, that means receiver is not ready to accept the frame. And if it is 1 1, that means it is a selective repeat reject. This reject is basically the go back and reject, and this reject is basically the selective repeat reject. Now if we come to the unnumbered frame, here it contains the unnumbered function bits. An unnumbered frame will always start with 1 1 in case of this control field. Now if it is an information frame, it will carry the user data here. If it is an unnumbered frame, it will carry nothing, and if it is a supervisory frame, in the information part it will contain the supervisory type of information. Now we have discussed all these things. Here the segregations: unnumbered frames used in link setup and disconnection, and hence do not contain any acknowledgement. Information frame basically carries the user data. Such frames can piggyback acknowledgement in the case of asynchronous balance mode. And supervisory frame, which is used for error and flow control purposes, and hence control the send and receive sequence numbers. Now basic use of the unnumbered frames. The unnumbered frames can be grouped into the following categories: mode setting commands and responses, recovery commands and responses, and miscellaneous commands. So that's all for HDLC, high level data link control.